If you think you're safe from violent tornadoes because you aren't living in the tornado alley, you could be dangerously wrong. It's shifting to the east. It looks like we're about to see fewer single tornado days and more days with multiple powerful tornadoes. And because they're shifting into more populated areas, they could take more lives and ruin more homes. There isn't enough time to build infrastructure to protect everyone from this fast-moving danger. So the least you can do to save yourself is learn as much as you can about it. About 1,200 tornadoes hit the US every year. You gotta thank the unique geography that sets up the perfect conditions for it, especially in spring and summer. Winds from the Pacific drop moisture over the Rockies and become dry and cool as they move east. They collide with warm, humid air streams from the Gulf of Mexico over the flat terrain. And that's how unstable air and wind shear, which are the perfect conditions for tornadoes, are born. Historically, tornadoes were most common in Tornado Alley. This term was first used in the 1950s by two meteorologists as the title for their research project to study extreme weather in Texas and Oklahoma. Northeastern Texas and south-central Oklahoma are precisely the areas we think of when we talk about Tornado Alley. But in the past 10 years or so, it has shifted eastward by up to 500 miles. Now, eastern Missouri, Arkansas, western Tennessee, Kentucky, northern Mississippi, and Alabama see more tornadoes. The storms of early 2023 are great proof that this trend is real. A violent tornado hit Rolling Fork, Mississippi, and another outbreak caused huge damage in the new Tornado Alley. Data from the past 2 years shows that large tornado outbreaks with multiple twisters from a single weather system are also moving eastward and becoming more frequent and intense. The Tornado Alley is shifting eastward mainly because of supercells. Those strong thunderstorms with rotating updrafts create new tornadoes. Supercells form when warm, humid air near the ground interacts with cool, dry air higher up. You can say that we're living in the middle of a natural experiment. We see changes in the basic ingredients for severe storms. But we don't know how significant these changes are. Experts predict that supercell storms will become more frequent in the late winter and early spring and less common in the late summer and fall. The air in recent years is getting warmer and moister, and the interactions between air masses more and more common. Experts explain that the atmosphere is becoming more unstable and the Gulf of Mexico sends more water vapor into the southeastern U.S. All these factors fuel the storms. Research also shows that the so-called dry line, which divides the wetter eastern U.S. from the drier western U.S., is shifting eastward too. This line has traditionally fallen along the 100th meridian, but has moved about 140 miles east since the late 1800s. This shift can affect where storms form, as the dry line works as a boundary for convection, where warm air rises and cold air sinks, fueling storms. Milder winters we've seen recently also mean more opportunities for unstable air masses to interact and form supercells earlier in the year. It's tricky to predict how the situation will change and how dangerous it is, because we don't have that much data on how weather patterns affect such short-lived events as tornadoes. The U.S. National Weather Service only began keeping tornado records in 1950, and they didn't catch many tornadoes in remote areas. Data shows that the number of days with tornadoes each year has decreased, but there's more tornado activity on those days when they do occur. The records also show that some years, tornadoes take the lives of up to 20 people across the U.S., and in other years, they take over 100 lives. But now, there are more people living in the paths of tornadoes because the U.S. population has more than doubled since 1950. And the Southeast, where tornado activity could go up, has way more residents now. Texas and Oklahoma are well prepared with tornado shelters. But areas in the Southeast are less equipped. Plus, there are many mobile homes in the Southeast which are vulnerable to windstorms. Tornadoes in this region often strike at night, and they are 2.5 times more likely to cause fatalities. We could possibly have more events like the 2008 Super Tuesday tornado outbreak. It hit the southern U.S. and lower Ohio Valley, and over just 15 hours, 87 tornadoes rushed through the area and caused massive trouble. 57 people lost their lives across 4 states and 18 counties, and many others were injured. The tornadoes were fueled by strong low-pressure systems that brought record warmth. There were supercells and rotating winds that produced these violent tornadoes. Early on February 5th, a squall line developed from eastern Texas to Missouri and moved east. One of the most intense tornadoes traveled 122 miles over 2 hours. By the early morning of February 6th, the severe weather threat shifted to the eastern U.S. It caused wind damage as the cold moved out to the Atlantic, with snow and freezing rain from Iowa to Quebec. It ruined many homes and even swept some of them from their foundation, made mobile homes fly, blew many vehicles and tractor trailers off Interstate 40, and threw some cars on trees. There were wind gusts over 50 miles an hour from Arkansas to Indiana, hail the size of softballs, toppled trees, and power outages everywhere. Some areas were flooded because of heavy rains and melting snow. All this led to over 1,000 flight cancellations at Chicago's O'Hare and disruptions at Toronto's airport. The data from scientists can help new areas of the U.S. prepare for more tornadoes coming their way. The people in authority will also need to improve community shelters and warning systems and educate the locals on tornado safety. You can also get prepared by learning 3 basic rules: get in, get down, and cover up. When you hear the warning for an upcoming tornado, get into the most interior room in your house and stay away from doors and windows. If you have a basement or an underground tornado shelter, hide there. If not, just be on the lowest floor possible. You can use whatever's at hand to protect yourself from debris. Clothing, pillows, blankets, a mattress, or a bulky table. Anything will do. There's a tip that says that the bathroom is the safest place to hide. It makes sense because those are mostly right in the center of homes. In March 2023, a man and his girlfriend in Rolling Fork, Mississippi survived a tornado in their bathtub. It got thrown into the air but landed safely amid the wreckage of their mobile home. But there's actually nothing extra safe about being in a bathtub with a mattress. Closets and walk-in showers that are deep inside the building can also offer good protection. Don't use elevators. You can get trapped inside if there's a power outage. Stay in your shelter until you're sure the tornado threat is over. If you can, listen for updates from the National Weather Service, local radio, or TV. Multiple tornadoes can hit the same area, so it might not be safe to leave even after one has passed. When you do leave your shelter, be very careful. There could be flooding, debris, collapsing buildings, and blocked roads. Stay away from fallen power lines and puddles with wires in them, and don't use matches or lighters in case of gas leaks. Stay away from damaged buildings as they could collapse at any time. Being in a car during a tornado isn't much safer than being out in the open or in a parking lot. Many people get injured trying to drive away from storms. Tornadoes can produce hailstones the size of softballs and can easily smash a windshield. If you find yourself outside when a tornado hits, try to get inside any building you can find. If that's not possible, get as low as you can. Even a ditch or culvert can be safer than your vehicle.
You lie down facing the scorching sun in the middle of the desert when suddenly you smell something extremely foul. You try to crawl to the source to see if maybe someone there can help you, but all you see is a large hole in the middle of nowhere. You crawl there and stick your head down the hole. You hear something really faint down there, but it's too dark to see anything. Still, the foul smell tickles your nostrils. You turn away in disgust and stand up to get a better view of it. The hole is roughly 100 feet in diameter, with nothing around it. You've been wandering around the desert for days and just ran out of food and water. But far away, you see what looks like a small hut. You walk there for another couple of hours until you reach the outskirts of a village. A local man riding a camel tells you that you're in the Al-Mara province in Yemen's eastern region, which is quite close to Oman. He immediately takes you to his mud hut, feeds you, and gives you some water. Feeling refreshed and full, you ask the local about the hole in the desert floor. His eyes sink in and his face grows pale. He grabs you by your sleeve in silence, throws you out of his hut, and slams the door shut. You try to knock on his door once more, but he ignores you. Out ahead is the village market, where you could surely get some answers from people. You head over there, and everyone starts staring at you as if you're some kind of threat. They sense something's off about you. You put on your hood and make your way to a merchant. While you purchase some food, you ask the seller about the hole, but he refuses to sell you anything. He even pushes you off to the pathway. You make your way to another vendor and ask about the hole. At first, he's reluctant to tell you anything, but after you buy a few items from his shop, he finally concedes. He takes you to a small inn and seats you down. He tells you to keep your voice low when talking about it. He then orders a beverage for you and begins explaining everything he knows about the hole. Legends have it that the Well of Barhut, which is in Hadramaut, is a cursed place, a prison for spirits. He claims that any object that goes near it eventually disappears. The server comes back with 2 refreshing drinks, and the man quickly stops talking. As soon as the server leaves, he resumes telling you about the well. The reason why people were avoiding you when you mentioned the well was because it's believed that it brought bad luck to anyone who was near it. They were even able to feel it through you. The man tells you that he doesn't believe in such superstitions, but you want to find out more. At night, you head back to the well to find out if what he said was true. You sit down next to it and concentrate all your senses. It's quiet, nothing but the desert wind brushing against the sand. You hear something that sounds like a whisper coming from the hole, as if calling you to go inside. You get up from your meditation and walk towards the hole. The sound gets louder, but you still can't make anything of it. You stick your head down the hole to listen while holding your breath, but it just sounds like gibberish. The next day, you get some rope and pikes and wait till nightfall to prepare for the next step, descending down the hole. Nighttime comes again, and you set up the ropes and tie them around a tree. You climb down while holding the rope with one hand and a torch with the other, and scale down. You try to breathe through your mouth, but you start to feel like you need to catch deeper breaths the lower you go. The hole is believed to be around 850 feet deep, but you were only able to go down around 20. You didn't expect it to be that deep. You start climbing back up, but you decide to drop the torch into the hole to see how far it goes. You see the flame getting smaller and smaller as it disappears into the darkness. Maybe the man was right, just village folklore about something they can't explain. Scientists claim that the hole is millions of years old and has practically no ventilation. Even though it's been around for such a long time, it remains as mysterious today as it's always been. You're walking in Siberia, looking out for some reindeer, when suddenly you hear a loud explosion from the distance. All of your reindeer scatter around, and you're too much in a frenzy to collect them. You run to the source of the blast and find a huge crater in an area you just passed through. In August 2020, a massive hole was discovered in Siberia, Russia, being around 100 feet deep and around 65 feet wide. The local residents and researchers were stunned to find it there. This is the 9th hole documented in the region since 2013. You call the local authorities, and a huge team of scientists arrive with weird-looking scientific equipment. They claim this crater is the biggest one they've seen so far. Most of these craters were found by accident when people went on non-scientific outings by helicopter or by hunters and herders. Scientists aren't able to wrap their heads around it, but they knew exactly where to start. Permafrost, the thing that covers 2/3 of the whole country's territory. Scientists believe that by studying the permafrost, which contains certain chemicals, we can find out why these craters are popping out. Samples of the craters contain a lot of chemicals, but most notably, methane. Scientists took plenty of samples of the frozen soil from the ground and the ice. They had to descend down the crater to collect most of them. And within 2 years, these craters end up turning into lakes. According to their studies, the gases, which are mainly made up of methane, accumulate in the upper layers of the permafrost, and they can come both from the deep layers of the earth and those close to the surface. These gases end up getting trapped in the frost as they accumulate. creating enough pressure to burst through the frozen ground. They claim that these giant holes are a result of the growing temperatures. But that's just one theory. They're still not really sure how they could have formed. But because most of these craters form in remote areas of the Arctic and take years to shape, no one really talks about them. You're fast asleep in the city of Fukuoka, Japan. At around 5 a.m., you hear a loud explosion and feel the ground shake. Japan is prone to earthquakes and tsunamis, so you're prepared for the worst. But the ground isn't rumbling and the building isn't shaking anymore. You check the power, and nothing. The whole apartment and neighborhood is completely dark. You look far out from the balcony and see a huge hole in the middle of a 5-lane road. You leave the building and join the crowd gathering outside. The hole is about 65 feet deep, and it swallowed everything around it. The traffic lights, sidewalks, and a bus stop are all gone. Even parts of buildings are destroyed, leaving the support beams still standing. The whole subway system is totally dysfunctional, and about 800 households are experiencing blackouts. Even the airport and subway had a bit of it. The local authorities evacuate the entire area in case more sinkholes or gas explosions occur. A few days later, it's all fixed. It only took the Japanese engineers and contractors 48 hours to fill it up, and a week to reopen the road to the public. The explosion might have been caused by some construction on a subway line, but the sinkhole is sinking again. People noticed that the road seemed to decline by about 3 inches in heavy traffic. But with quick maintenance, Japan can fix anything in the fastest way possible.
Ladies and gentlemen, your attention please. All right, just listen up. The Guinness World Records Award for the deepest human invasion into the Earth's crust goes to the Kola Superdeep Borehole. Ooh. Its depth is 7.4 miles. You can find it in the icy part of Russia where the winter temperature of minus 40 degrees Fahrenheit is a common thing. Well, that's chilling. Local scientists started to dig it in the 1970s. The grand plan was to reach a depth of 9.3 miles. It was a purely scientific project to study the Earth's crust and maybe get to the hot mantle. Well, when it's so cold outside, it kind of makes sense. Up to the depth of 4.3 miles, the drill easily coped with granite rock. Then, denser layers came and broke the drill. The scientists had to change the drilling pattern. In the end, it resembled a tree with many branches. The deeper it went, the hotter it became. The temperature went up to 350 degrees. The equipment was constantly out of order and work was stopped completely in 1992. If you see this legendary place with your own eyes, you'd hardly realize there's an abyss right beneath your feet. The borehole looks like a rather small and unambitious hole in the ground. The place is now abandoned, overgrown with moss and rust. It has its fair share of myths surrounding it too. One of them says people hear strange sounds like moans and screams from the depths. In reality, of course, none of this is true. At the time, many countries were engaged in the study of the Earth's crust. For example, Germany. They duly noted the experience of the Kola borehole and made a super tech drill that could withstand extreme temperatures. A location was chosen in Bavaria at the junction of 2 tectonic plates. In the past, they were the shores of an ancient ocean. In the early 90s, a group of researchers began drilling a well there. But already at a depth of 4 miles, the Earth fought back. It deflected the drill from the vertical, and then the temperature made a surprise spike to 520 degrees. All these problems forced scientists to stop at a depth of 5.6 miles. In 1977, a company in Austria started drilling a well at a site with plentiful resources, or so they thought. They did find large gas reserves, but there was an unexpected problem. As the drill entered the chamber, the well collapsed. They tried again and made a new, even bigger borehole that went as deep as 5.3 miles. But ironically, they weren't able to drill into the gas chamber again. In Sweden, expectations from drilling weren't met either. At the site of a huge crater 30 miles in diameter, they started the search for gas and oil. It's the largest crater in Europe, which must have appeared because of a meteorite. The well went deep, but unfortunately, nothing of interest was found. At 4 miles down, the drilling stopped. One of the deepest oil wells in the world is Bertha Rogers in Oklahoma. Its depth is almost 6 miles. In 1974, the Lone Star Company achieved such a stunning result in just over 500 days. For 5 years, it was the deepest borehole in the world, until the Kola Superdeep was drilled. Bertha Rogers could probably have gone even deeper, but the drill suddenly struck a molten sulfur deposit. It grew solid around the drill string, breaking the rig. If you can't get to the Earth's mantle from the ground, do it from the water. Project Mohole was just about that. It got its name from moho, the threshold between crust and mantle, and, well, a hole. You know, moho. Well, anyway, the project was launched in the 1960s and was overseen by the U.S. National Science Foundation. The crust on the ocean floor is thinner than on land, and the mantle is closer. Scientists had hope that a 3-mile deep underwater borehole would bring them there. They chose a location in the Pacific Ocean, where the bottom was at a depth of about 2 miles. There were 2 phases planned for the project, and the first was a success. A total of 5 wells were drilled, each not exceeding 600 feet in depth. Unfortunately, the second phase never happened. Too many problems were involved. So, apparently, there ain't no moho, holes. Today, underwater wells are commonplace. Their main purpose is extraction of oil and gas. The EVA 4000 American drilling platform is located in the Gulf of Mexico. This huge structure rises above the water at a height of a 20-story building. The platform moves around looking for oil at depths of over 6,000 feet, and when it finds a good spot, it's capable of drilling up to 6 miles into the seabed. Now, let's move to Africa. Here at the very south of the continent, there's a huge quarry, the Kimberley Diamond Mine. Now, it's easy to drill through the ground when you have the best equipment, but this hole was literally dug by hand. About 50,000 workers dug it tirelessly in the late 19th and early 20th centuries using ordinary shovels. And no, they hardly wanted to get to the opposite side of the earth. They were attracted by the enchanting brilliance of diamonds. One of the most famous precious stones, Tiffany, weighing 128.5 carats, was found in the Kimberley mine. The depth of the hole reached 790 feet. Just imagine how difficult it was to return from work. It was like climbing 66 floors on foot. When the work stopped, the bottom of the pit was partially filled with soil, and then water flooded the place. Today, it's a popular sight among tourists, and surely, each of them secretly hopes to find a diamond there. With the industrial boom, oil became even more popular than diamonds, and the oil wells around the world are getting deeper. For example, in 2008, Qatar drilled the longest oil well at that time, El Shaheen. It was 7.6 miles long, and it only took them a little over a month. The vertical part of the shaft reaches 6.7 miles. Stretched up instead of down, the shaft would reach the height of commercial airplane flights. The record was broken in 2012 by the Z44 Shavo oil well. When they measured its length, the new hole beat the one in Qatar by about 300 feet. Just for a clearer picture, either of these 2 oil wells would fit almost 15 Burj Khalifas or 40 Eiffel Towers. Moving on to Canada and high up into the sky to look at it from space. See those 2 huge holes? If you don't know, those are diamond mining sites. You might think that an alien invasion happened while you slept right through. This enormous place is on the island of Lac de Gras, not far from the Arctic Circle. This is a whole city with industrial and administrative buildings, a boiler house, living quarters for workers, and even an airstrip. In 2018, the largest diamond in North America was found here. It weighed 552 carats. Apart from diamonds and oil, the bowels of the earth have a lot of other useful stuff. One example is copper. Let's go to Utah and see the giant Bingham Canyon mine. Copper has been mined here for over a century. The width of this quarry reaches 2.5 miles, and it goes half a mile down. Just imagine how breathtaking a paragliding flight would be over this powerful structure. But the greatest treasure of the planet is, of course, fresh water. And to get to it, people would dig as deep as they have to. The deepest water well in the world is found in Great Britain. It was dug by hand in the 19th century. People just had to keep on digging because they couldn't get to water, and as a result they reached almost 1,300 feet. When the water finally gushed from under the ground, the workers barely managed to escape from the well. Many of us spend a huge part of our life under the ground. Yeah, I mean the subway. The deepest underground station in the world is in Kyiv, Ukraine. It takes over 5 minutes for the escalator to lower you to the platform. After all, you're traveling nearly 350 feet down. Sometimes nature decides to dig something deep on its own. Most likely, the Mariana Trench is the deepest point in the ocean. Its bottom, called the Challenger Deep, is 6.8 miles below sea level. Sunlight never gets there. The pressure down below is more than 1,000 times higher than on the surface. If you decide to dive to the bottom, you'll spend 4 hours of your time and a whole lot of money on the necessary equipment. Scientists have even found mountains there. By the way, if Everest was moved to the bottom of the Mariana Trench, we wouldn't be able to see its top on the surface. A little riddle: can you dig water? The answer is yes, if it's in the form of ice. The Uran Observatory in Antarctica made it by digging boreholes up to 1.5 miles deep using hot water. Optical detector filaments pass through them. They capture elementary particles, neurons. In fact, this is a telescope that's directed not upwards but downwards into the ice. But that's a completely different story.
There are many miles of undiscovered areas beneath the crust we can't even come close to. Scientists found what appears to be underground mountains buried inside the mantle. Our planet is divided into 3 layers: the crust, the mantle, and the core. The crust is where 8 billion people, trillions of trees, and millions of animals live and thrive. There are also different types of crust in the land and the ocean. The oceanic crust contains unique rocks and is denser than the land crust. We all see how the Earth is divided and color-coded to show the crust, mantle, and core in textbooks. But there are also special layers in between that not everyone talks about. The mantle is divided into the upper and lower part, which is the transition zone. Since the mantle acts as the geological recycling center, the plate tectonics don't only move side to side, but up and down. It's actually why all the volcanoes appeared. The magma spews out to the surface or even underwater, and then sinks back down and repeats. The transitions go down 250 miles and then 410 miles. And in this bottom layer, scientists keep discovering the hidden landscapes. The mountains in the mantle are more rugged and much larger than the ones on the crust. Scientists found a mountain range with peaks higher than Mount Everest. Some of them are as high as 600 miles. When the continents were still landlocked together, there may have been some hidden lands now underwater. Theories suggest that Iceland used to be part of a larger microcontinent, Icelandia, which connected present-day Iceland with Greenland and Scandinavia. The idea digs even deeper to a greater Icelandia, which includes Britain. But after the split, these bigger lands sunk with everything in it. There are also theories about New Zealand being part of Zealandia, a hidden microcontinent within the same region. So it could be that these mountains used to be part of old Earth that are underground over the billions of years of natural occurrences. But still, it isn't very likely. One theory is that these underground mountain ranges could be leftover slabs of rock that descended from the surface to the transition zone from the moving of the tectonic plates. As they sink, the large pieces break down into smaller ones, and as they compile over the millions of years, they form what appears to be underground mountains. Since the mantle is the geologic recycling zone, it's likely that the rocks down there used to be part of the surface. They weren't large pieces of land that got hidden, just like dogs hide bones in the garden, but it takes way more time to hide mountains. Some parts of the mantle appear to be smooth, while others aren't so much. The parts that have a cluster of rocks could contain hidden elements in the underground mountains. The smoother parts don't have much seismic or volcanic activity, while the rough parts do. The best way to study those underground landscapes is to wait for an earthquake or a volcano eruption to happen. Seismologists can observe the Earth's interior with special scanners, just like doctors use ultrasound to examine a patient. They can even see minor details and not huge chunks of rocks. A strong enough earthquake can send shock waves to the Earth's interior, even through the core and back up to the surface. Depending on where they occur, seismologists can observe and study the intensity of the waves as they move back and forth. On smooth rocks, the waves can travel in a straight line, but once they reach a rough area, the waves tend to scatter. The temperature and composition of the materials can make the waves move faster or slower, but this info isn't exactly accurate and won't contribute a lot to the actual data of the underground mountains. So, by analyzing the scattered waves on ships and utilizing the Earth's magnetic field, scientists can figure out everything they need to know. But these studies are only good enough to figure out the interior in today's state, not how the Earth changed over the past 4.5 billion years. However, scientists are certain that mantle material still dates back to the beginning of Earth's original formation. The question, why not just dig a hole to the center of the Earth and see what's going on down there, might seem logical. The deepest hole humans have dug so far is the Kola Deep borehole in the Russian Arctic that goes more than 40,000 feet deep. The locals claim they can actually hear screaming coming from below. It took almost 20 years to drill as far as they went, but it's literally merely scratching the surface of what's underneath. They dug about 1/3 of the crust, which is only 0.2% to the center of the Earth. Getting there is beyond us, just like trying to reach the sun. No human can handle the amount of pressure down there. Going down the Mariana Trench, the Earth's deepest point, requires special gear to withstand all the immense pressure. It'll cost a fortune to build that tech to get us to the center of our planet. Evidence of diamonds buried deep in Brazil shows that everything we do on the crust's surface can affect things miles below, even towards the mantle. Scientists dug up 6 diamonds that could hold tiny mineral grains. As they're called in the mineral world, these inclusions have a chemistry composition where they originated deep in the Earth. Typical diamonds are formed at depths less than 125 miles in the upper mantle, where it's extremely hot. The high pressure and boiling temperature down crystallizes carbon and creates diamonds. But humans can't dig all the way down there. They mine them by detecting where a deep volcanic eruption happened that expelled these diamonds to the surface. These eruptions occurred millions of years ago, when dinosaurs used to rule the Earth. They shot out the diamonds that were in the mantle and are now embedded within the cooled down volcanic material. That's where people mine them. But these special diamonds found in Brazil originated from a much deeper point than usual, which can further help scientists study the depths of the Earth. They can extract these inclusions and analyze them in a lab to tell where exactly these minerals come from. In the lab, scientists study inclusions, each just 15 to 40 microns wide, less than a quarter width of a human hair. They found out that they contained many types of minerals found in volcanic rock on the surface. The carbon composition of the magma from the surface is much different than the ones deep in the Earth. What's crazy is that these diamonds with special inclusions can only be found 435 miles in the lower mantle. With only a few samples of them found, we don't know what else lies beneath us. It's possible that those mountain ranges underground, taller than Mount Everest, can have traces of diamonds all around, which would prompt excavators to dig them up and saturate the market with them. These diamonds are less flawed than the usual ones and might even come in many sizes. It's possible to see diamonds as large as a car or as small as a grain of rice. There might even be new diamonds with different chemical compositions than the ones we find near the surface. The largest diamond in the world is the Cullinan, which can fit in the palm of your hand. It weighs around 1.3 pounds and is 3,100 carats. It was found in 1905 in South Africa. For anything to exist on Earth, you need carbon. In a nutshell, the The carbon cycle is when plants and algae release carbon dioxide into the atmosphere or dissolved in water through photosynthesis. It's converted into carbohydrates and stored as fat. Later on, carbon dioxide is released into the atmosphere through breathing, which the plants benefit from, and the cycle goes on. Scientists claim that there might even be a carbon cycle in Earth's interior. The oceanic crust has a lot of carbon sediment that could mix with the upper and lower mantle layer. But there still isn't enough evidence to support this. The deep diamonds might be the key to popping open that theory. Only time will tell. There's not much to do in Antarctica except scientific work. You could check out the wildlife, like some cute penguins and seals, and you'd get to see the occasional whale swimming around. Antarctica is one of the biggest lands out there that's only inhabited by scientists and researchers from all over the world. These scientists dug a hole through some pretty thick ice to study the ancient air and how the atmosphere cleans itself. They used a special drill and dug a clean cylindrical hole 450 feet below the surface. Some of this ice can be up to 800,000 years old and is a good indicator of what the climate was like in the past. It's like checking out tree rings to determine how old a certain tree is, except it's more complicated than that. After the effortless digging, they decided to drop some ice to the bottom of the hole to see what would happen next. They heard some really unusual sounds. It felt like being on a spaceship traveling through a bunch of obstacles with many rocks smashing into each other. The pitches changed over the quick descent of the block of ice, ranging from high pitch and ending with a low heartbeat-like sound. The scientists were puzzled when they first heard this and dropped some more ice, only to find out that the same type of sounds were being produced, just in different variations. They couldn't tell what was down there, and, more importantly, why these kinds of sounds were produced. Antarctica boasts quite a few volcanoes, many of which are under super thick sheets of ice. Scientists discovered 91 volcanoes and claimed there could be more, potentially making it the most extensive volcanic region in the world. While they were doing regular scientific research, they came across many unmistakable large cone-shaped figures underground. Some were as deep as 2 miles in the ice. Some of the peaks were over 3,000 feet tall and dozens of miles across. But on the surface, it's as plain as a sheet of paper. They may have dropped that block of ice inside an actual volcano that they were standing on, but it's unlikely. Even though the underground volcano presence was discovered by accident, there's a small chance they were actually standing on one where they had their workstation set up. It's more likely that they worked in an area where studying ancient climates is easier and less dangerous than other places. They collect ice samples and study them in a lab. It's like discovering a prehistoric insect embedded in amber millions of years ago when dinosaurs used to roam the land. But instead of little bugs, scientists study ancient dust, air bubbles, sea salts, volcanic ash, and anything else that may have come from the environment. They can practically tell how the climate was during that time. These ice samples might show that Antarctica's western ice sheet melted when the Earth's climate warmed up. If it did, then it's likely to happen again. That would mean sea levels rising, affecting coastal cities and small remote islands. But scientists aren't sure it's true, despite some evidence to back it up. The process of studying ice samples can take a week or even a year, depending on what they find. They crush or melt the sample bit by bit. And like those tree rings, the deeper the layer, the further we go back in time. In order to study ancient bubbles trapped in ice, researchers have to crush the samples under a vacuum hood to keep the air out while extracting the air and putting it in vials. There are various instruments and devices to study the ice samples, but because it's so sensitive to damage, each measurement must be in a clean room setting so that nothing gets compromised. The scientists have to wear proper bodysuits and many layers of gloves and constantly get ventilated. Even something as tiny and insignificant as a fingerprint can ruin a sample. They look for certain patterns to see changes in the atmosphere's composition and temperature. But dropping a few blocks of ice down a hole wouldn't be so bad. The reason why it made such a peculiar sound is the same reason why a moving car sounds different when it's honking than when it's stationary. The scientific word for it is the Doppler effect. It's an obvious change in the frequency of a wave with respect to an observer who is moving relative to the wave source. The effect doesn't mean the frequency of the sound changes, it just shifts. And this can be said about other types of waves, like water and light. But sound waves are the most popular ones when it comes to the Doppler effect. So, when the scientists dropped the ice block down the bottom of the hole, the sound waves traveled back up and bounced around the narrow tube where they drilled. That's why they got the pew pew sound. Let's not forget that this ice block traveled 450 feet beneath us. Oil ships dig holes in the oceanic crust that go thousands of feet beneath the Earth. The Kola Super Deep Borehole in Russia is the deepest hole ever made by humans. It goes more than 40,000 feet below the surface and took almost 20 years to reach 7.5 miles. Below it is only half the distance to the mantle. In terms of the whole Earth, this very deep hole is literally scratching the surface. This wasn't a hole to dig for oil, and wasn't in the ocean either. The drilling was stopped in 1992 when the engineers found out that the temperatures were 100 degrees Fahrenheit higher than they predicted. And then it was abandoned, and it's just been a barren hole now. But that's the closest we've dug to the center of the planet. The scary thing is that some of the workers on the site could hear voices coming from within. All the way in Yemen, an ancient hole exists in Barhout, in the east of the country in the middle of the desert. It's actually closer to Oman than to the capital Sana'a. This hole has puzzled experts and locals. Unlike the holes in Russia and Antarctica, this wasn't man-made. Or was it? It's been around for many years, and the locals try to steer away from it. They don't even like talking about it, since they claim it brings bad luck to those around it, or to whoever utters its name. They claim it was created as a prison for spirits, but many rule that out. The hole is 98 feet wide and somewhere between 330 to 650 feet deep. You can also hear strange sounds coming from the inside. But according to some scientists, the well has little to no ventilation and barely has any oxygen down there. So it's unlikely that anyone or anything lives down there. The Challenger Deep in the Mariana Trench caught some low-pitched grumble sounds in March of 2016. Some of these grumbles were followed by screeches. They caught these sounds in a span of weeks, using a titanium-encased microphone so that the immense pressure of the lowest point on Earth wouldn't crush it. They had to lower it slowly as well, since it's 1,000 times the atmospheric pressure at sea level. For 23 whole days, the microphone recorded typical sounds of whales passing by and boats sailing across from above, and even rumbles of nearby earthquakes, but they still couldn't determine what caused those initial sounds. The researchers couldn't understand if the noise from the bottom of the Mariana Trench was caused by humans or was natural. They also wanted to know if these sounds affected marine life, like dolphins and whales that rely on echolocation. They still can't figure it out, but scientists estimate that the ocean is about 10 times noisier than it was 50 years ago. With technological developments in shipping, submarines, and underwater construction, the ocean will only get louder with time. Northern lights come with sounds, which nobody talks about. They're usually audible when the auroras are at their most powerful presence. Scientists were always puzzled as to what caused the faint popping and crackling, even though they were very far above us. They used some special microphones and found out that the sounds came just 230 feet above us, which is pretty low. They're caused by electrical charges gaining power in a specific region of the auroras. The electrical charges are disturbed by magnetic storms that fire up the northern lights. As a result, some tiny sparks are released into the atmosphere, causing the faint crackling and popping noise.
My, it's wet out here. In 2016, scientists decided to study the widest part of the Atlantic Ocean between Africa and South America. It's kind of lonely there. They went days without seeing a single plane or ship. It was mostly just dolphins and whales swimming by. They were in the middle of nowhere. So why? They were floating right above one of the most important geological spots on Earth, the Mid-Atlantic Ridge. It's where two monster tectonic plates meet. Tectonic plates are massive jigsaw pieces that are constantly moving, even though we usually can't feel them. They form the Earth's crust and, in this case, meet beneath the Atlantic Ocean. The researchers floated over the ridge and dropped down some instruments that detect waves, earthquakes, and other vibrations. A year later, they came back to collect the results. At first, the goal was to learn more about the history of the two plates. But the instruments picked up a whole lot more than that. They found out some stuff about the future, too. Way down at the bottom, there's a layer of extremely hot liquid rock that's constantly rising up, pushing on the tectonic plates and causing them to move apart from each other. That means that the Atlantic Ocean is expanding about 2 inches every year, pushing Europe and Africa away from the Americas. At the same time, its bigger neighbor, the Pacific Ocean, is shrinking. It's the biggest ocean, right now, with a huge area that's around 30% of the Earth's surface. Its average depth is 13,000 feet and is home to the famous Mariana Trench, the deepest spot in any ocean. And yeah, it's now shrinking by around 1/5 of a square mile per year. Some scientists even believe that eventually, millions and millions of years from now, the Pacific Ocean could completely disappear. This ocean is where we think most earthquakes happen, plus it's where a lot of the world's volcanoes are. All that causes lots of shaking. Plates move around and old parts of the Earth's crust get destroyed. The ocean floor can't grow fast enough to replace it. This means some big changes are coming in the future. A couple of inches isn't exactly a big deal, but after a few 100 million years, there'll probably be a new supercontinent on Earth. Australia is slowly heading north, and it could eventually collide with Korea, Japan, and eastern China. Africa is moving too. In 50 million years, it'll be pushing right up against the southern parts of Europe. Since it's all happening so slowly, I've had a chance to think up some future scenarios. Okay, not me. A bunch of super brainy scientists with even brainier computers. The first scenario, a monster landmass called Novo. The Americas would slam into Antarctica, then they'd team up and head over to Africa. Meanwhile, Africa would have already smashed into Europe and Asia. Not bad, at least you'd save some money on plane tickets. But for most people, it would take an epic road trip to get to a beach somewhere. The second scenario is Ultima. I feel like these all sound like car names. Anyway, in this scenario, the Atlantic stops getting wider. Actually, it's the opposite. It starts closing in on itself. This new super cool continent would be surrounded by the Pacific Ocean. Scenario 3. Orica. Both the Atlantic and Pacific Oceans eventually shrink down until they either disappear or end up like tiny little lakes. All the life in these two oceans is gone. Instead, some new ocean starts forming to replace them. And the new supercontinent? It has Australia in the corner, with the Americans and East Asia each on the opposite side of a small puddle that used to be the Pacific. The rest of the planet is one big unexplored super ocean inhabited by… who knows? I won't be around then. Number 4. Amasia. There's that car thing again. This one predicts Africa, Australia, and all the continents except Antarctica start moving north. Sorry, Antarctica, even planet Earth keeps forgetting about you. Better luck next time. Well, way off in the future, it might be possible to take a big old road trip across every continent, or drive across the African-South American border, or even get to Australia without having to take the longest flight of your life. But we've got a while to wait. What should I do for the next 250 million years? Binge watch some Brightside? Tectonic plates move at different speeds, some slower, some slightly faster. Your hair and fingernails actually grow at roughly the same speed as these beasts move. Imagine if everyone lived on one of those supercontinents. Animals would finally be able to cross continents and meet species they've never seen before. Leopards, rhinos, lions, elephants. Imagine if they got curious enough to set out on a journey out of their habitat. A lion might meet a polar bear. Kangaroos could finally leave the land down under, and birds that migrate to warmer places would have to totally reorganize their travel schedules. Who knows what the climate would be like? Playing around with the continental jigsaw puzzle isn't exactly a new thing. Our world didn't always look like this. 300 million years ago, our planet didn't have 7 continents. It had only one, a supercontinent called Pangaea. Pangaea was surrounded by only one ocean. Over time, it slowly started falling apart. At one point, South America, Antarctica, Australia, and Africa were one unit, and North America and Eurasia were another. Over time, these continents also splintered off, each heading in its own direction. Scientists have discovered many similar plants and animal fossils on continents that are separated by huge oceans. Even when you just glance at a map, you can see how Africa and South America look like two massive puzzle pieces that fit together perfectly. When you look at all the oceans and seas on a map, it may look like they just flow right into each other, like there's only one big ocean and people gave different names to different parts. You wouldn't think that if you've ever been to the place where they meet. The Atlantic and Pacific have a strict border that looks like an invisible wall separating two completely different worlds. You can clearly see different colors and waters, and they don't mix. Of course, there's no wall or any actual physical border, but not all water's the same. The Pacific and Atlantic have different densities, amounts of salt, temperatures, and a whole bunch of differences. The borders that separate two bodies of water are called ocean clines. The line you see dividing the Atlantic and Pacific Ocean is mostly caused by different salt levels. This is what layers of water with different salt levels look like. It's like they're separated with cling film, each one with a different color because it has different things growing in it. To see a clear, noticeable border, one sea or ocean has to be a whole lot saltier than the other. Want to get active and use up all the salt in your house? Pour some colored salty water or seawater into a glass bowl. Then add fresh water on top. Voila! The Pacific Ocean is the less salty one. That's because there are loads more rivers flowing into it. Heavier liquids are heavy, so they should sink to the bottom. But then, why is the border between the Atlantic and Pacific a vertical line and not a horizontal one? First, the difference in density of these two salty beasts may be enough to stop them from mixing, but it's not really enough to send one of them to the bottom with the other floating above it. There's another reason, and it's all about the Earth spinning around. Say you're flying from Chile to New England. If you fly straight north, by the time you get there, the Earth will have turned a bit, and you'd be nowhere near your destination. To get to the right place, the pilot needs to fly in a bit of a curve. That's sort of the same reason that currents move around in different directions. The currents in the Atlantic and Pacific Oceans move away from each other, so they don't really mix at their border, even though they're both just water. Confused? Yeah, me too.
When you think of a volcano, what's the first thing that comes to mind? Streams of red, steaming hot lava pouring over the sides? Dark clouds of ash rising high into the sky? Maybe you think of a relaxing hot spring. Ah, that's nice. Well, we all imagine one thing, a cone-shaped mountain looming over the horizon. But it can be as green and lush as any other mountain. At the top, of course, there's a giant hole, like an opening that goes all the way down. Inside, there's lava and gases being pushed outside. Lava is so hot that if you were standing at the top of the volcano and looked down, your face would feel as red as the color of that liquid rock oozing out. A volcanic eruption never comes without consequences for us. And I'm not just talking about people living nearby. The impacts are usually felt on a global scale, too. Can't fly for a while because of the blanket of ash released in the air. Not to mention, it might be a bit tricky to breathe. Carbon dioxide, sulfur dioxide, and plenty of other toxic gases whose names immediately take you back to your high school chemistry class. Funny enough, most of that cloud rising out of a volcano is just water. Well, vaporized from those scalding temperatures. But before any volcano erupts, it goes through stages like an angsty teen. First, magma, that's lava before it erupts onto the surface and gets its name change, starts moving underneath the volcano. This causes earthquakes that get worse and more dangerous over time. Then, steam and different gases start spewing out of holes in the planet's crust. Our Earth resembles a tea kettle about to whistle. When the gas emissions and earthquakes get more massive, it usually means the volcano is about to blow its top. But those first stages can take years before an eruption happens. Then, the magma starts building up. With more and more pressure, it's planning to make its great escape. It's hard to notice this happening if you don't have the proper equipment. Good thing scientists do, and they've got us covered. The volcano becomes more active by the minute. Ash starts coming out and spreading in the air, creating ominous clouds that turn day to night. With the magma building up, an eruption is imminent. Then, boom! The surface gives in under the pressure below. The magma makes its exit. It's now lava, spewing out the top and flowing down the sides of the mountain. None of this sounds very appealing. So, what if it never happened? What if there were never any volcanoes at all? Would Earth still be the same? Not at all. If volcanoes never existed, there wouldn't be an atmosphere. When our planet was still just a young pup, volcanic gases are what created our protective bubble that allows you and me to breathe right now. They also played a big part in shaping the land and oceans. 4 billion years ago, Earth was still forming. It didn't look anything like the pale blue dot we know today. It was red hot, and the water was trapped under the crust. It wasn't until the surface started to cool down and solidify that the water was finally able to escape. Volcanoes acted sort of like a tear in the fabric of our planet. Water vapor would condense in the atmosphere and then fall back down as rain. It rained for so long that the third planet from the sun started turning into the blue ball we're more familiar with. In fact, there's even a theory that all the water on Earth came from volcanoes. And without water, of course, life wouldn't have been able to form. Land formation went through a similar process. You see, our planet was a pretty rough place to be when it was forming. It was a molten surface with fields of lava and constant volcanic eruptions and space rocks always crashing into it, because there was no atmosphere to protect it. When it started cooling down, a good solid surface formed, but the hot material underneath was still boiling and bubbling, and it continued making its way up. The crust would move and form thick layers with the material that was rising up. Over time, these layers became more permanent. Volcanic eruptions were still happening, but the first landmass had finally formed. Okay, we'll take the best part of volcanoes, an atmosphere. So what if they stopped erupting long after we got our protective breathable shield? Still not good. For starters, volcanoes created the most fertile soil. Around Naples, you have the famous Mount Vesuvius. The soil quality there is incredibly rich, and that's thanks to 2 huge volcanic eruptions, one that happened 35,000 years ago and another 12,000 years ago. Sure, these volcanoes caused a lot of short-term damage, but in the long run, these soils were fertilized by them. Now the region grows all kinds of citrus fruits, olives, grapes, cherries, and of course, their staple, tomatoes. There'd be none of that without rich volcanic soil, and Naples is by far not the only example like this. Bacteria, the first living organisms, lived in hot water. Scientists have discovered fossilized microorganisms older than 4 billion years. They thrived in hydrothermal vents. Those are fissures on the sea floor, and they're usually near volcanically active places. This means that without volcanoes, we wouldn't have land, water, or even the first life forms that, as the theory goes, would eventually evolve into all the creatures we have today. Could life have still developed on Earth without these explosive mountains? Doubtful. Okay, fair enough. We want our atmosphere and life. So let's say volcanoes stopped erupting today, after we already have all these benefits. Well, we're sort of already there, based on this story. At the start, there was only one continent, Pangaea. It was a supercontinent surrounded by one massive continuous superocean. Volcanic activity by this time had finally calmed down, and this meant all that energy would gather below the Earth's crust. Here's a little diagram. First, we have the Earth's inner core. Then there's the outer core. Next up, we have our convection currents. Magma is next in line. After that, the oceanic crust. And at the very top, we have our ocean and our continental crust. The reason Pangaea eventually broke up into the separate continents we have today is because of plate tectonics. It's not like the crust is all one solid piece. It's broken up into big chunks, or plates, that are always moving. And it's all still moving today. Yes, the land you're standing on right now is sort of surfing on that layer of convection currents. It's a slow process, so it's not like you can feel it. Pangaea didn't break apart all at once. It took tens of millions of years. When the plates move, they cause earthquakes and volcanic activity. They create mountains too. It's good for our planet as well, because the Earth gets to sort of renew its old crust. If there was no volcanic activity now, the pressure underneath the Earth's crust would keep building up. It'd get to a boiling point the continents couldn't handle anymore, and eventually, they'd start splitting into more numerous and smaller masses. Volcanoes are still useful to us till this day. For one, they cool our atmosphere. Their eruptions release sulfur gas. It combines with water in our atmosphere and cools it at its lowest level, which is where we live and breathe. There's also an excellent use for their heat. Geothermal power plants harness the energy coming from deep inside the Earth and turn its heat into steam. We then use that steam and turn it into electricity. This is the case for our friends in New Zealand and Iceland, since they live in places with high underground temperatures. Volcanic material can also be made into blocks for building stuff. It can be grounded down to make cement too. If we want, we can even search volcanoes for precious minerals like gold, copper, and sulfur. And who can forget about hot springs? Tourism to places like Yellowstone and Iceland wouldn't be the same without them. And who doesn't love a nice steamy dip in the ones safe for swimming? Oh yeah. In the end, volcanoes aren't so bad after all. Our beautiful Earth wouldn't be what it is without them.